Galileo Galilei was a pretty smart guy. For example, he correctly described the concept of inertia, which is the tendency of objects to stay at rest or in motion. Isaac Newton, another really smart guy, took this one step further, refining it to the point of a scientific law. Newton's first law, usually called the law of inertia, states that an object in a state of uniform motion tends to remain in that state of motion unless acted on by an outside force. By state of motion, we simply mean how it's moving or not moving. This is important because things aren't just mobile or stationary. There's all sorts of ways that objects can move. Slowly, fast, in circles, in a straight line, up, down. Well, you get the point. Galileo also understood this. Remember, smart guy. But at the time, people were just describing things in vague terms of slow and fast. Realizing that there was so much more to movement, he decided to find a way to describe movement better. In doing this, Galileo became the first to measure speed, the distance an object covers in the amount of time it takes to travel. In other words, how long does it take that object to go how far? Speed is a straightforward calculation. Just divide the distance by the time and you'll know how fast you're going. The best part is that you can use any combination of distance and time for speed. Kilometers per hour, meters per second, centimeters per day. The possibilities are endless. So you may want to think hard about using that last one, unless maybe you're a snail. Speed is a very useful thing, but what's even more helpful in understanding an object's state of motion is its direction. When an object has both speed and direction, this is the velocity of the object. Speed tells us how fast that object is going, velocity tells us how fast and where. For example, if a car is moving at 70 miles per hour, that is its speed. But if it's traveling 70 miles per hour to the north, then that's its velocity. Something that has a constant speed is not going slower or faster. For example, driving exactly 70 miles an hour the whole trip. But something can have constant speed without having constant direction. Think of a car driving in a circle. If it travels at the same speed the entire way around the circle, it has constant speed. But because it is constantly changing direction as it goes around, it definitely does not have a constant velocity. In order for an object's velocity to be constant, it has to move in a straight line at the same speed. Remember inertia? Since we now know that inertia is the tendency of an object to resist changes in motion, and motion is described by velocity, we can think of inertia in a new way, the tendency of an object to resist changes in velocity. Believe it or not, everything is always moving. You think you're just sitting there on the couch, but actually you're flying through space. Relative to things like the sun and the stars, you're moving pretty fast, at about 100,000 kilometers per hour. You don't feel like you're moving though, because relative to Earth you are at rest. This is why we say that motion is relative. It's relative to something else. When we say that our car travels 70 miles per hour, that's relative to the road. And a satellite travels at 300 kilometers per hour relative to Earth. Both Galileo and Newton understood inertia, the tendency of objects to stay in their state of motion. Moving slowly, fast, or not at all, state of motion simply describes how an object is moving. When an object is moving, we can describe how fast that movement is with speed. Simply put, this is the distance an object travels in the amount of time it takes to get there. Speed tells us how fast, but we need velocity to tell us where. This measure is speed with direction, 70 miles per hour north, or 300 feet per second southeast. In order for an object to have constant velocity, it must maintain both a constant speed and direction. Traveling in a circle means you're changing direction, and therefore your velocity. We often say that objects aren't moving, but really everything is moving all the time. Relative to the sun, we're speeding along like crazy here on Earth. But relative to the Earth, we're at rest, which is why you don't feel like you're going anywhere when you're sitting on the couch.